Hello, beautiful people, and welcome. This is part 2 of your pre-quiz for Module 12. Just a disclaimer, we are on campus, so if you hear a loud bell or the intercom go off, I apologize in advance. Also, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I can fix it and we can both learn from my mistake. We are starting with question number 4. It is asking us to find the 8th term. Now this is very similar to question number 1 because it doesn't tell us if the sequence is arithmetic or geometric, so we have to figure that out. And the way to figure out if a sequence is arithmetic or geometric is to find the pattern, or you can do is take the right term and the left term and either subtract it or divide them and see what the pattern is. So I choose to identify the pattern. So for example, I notice that 4 and 20, I'm going to multiply by 5. 20 times 5 is 100. And 100 times 5 is 500. And of course, all of these terms are negative. So that way I can see that I multiply every single jump. So that means I have a common ratio. And my common ratio is 5. I know what a sub 1 is. My first term in the sequence is 4. And it's asking to find the 8th term. So I'm going to use the geometric sequence explicit formula. So a sub n is equal to a sub 1 times r to the n minus 1 power. A sub n, we are trying to find the 8th term. So in the 8th position, n is now 8 is equal to a sub 1 is negative 4 times r, we know r is 5, and we know n, again, is 8. So I have a sub 8 is equal to negative 4 times 5 to the 7th power. And again, I probably should be able to know what 5 to the 7th power is, but I did not, so trusty calculator it is. So 5 to the 7th power is a very big number. So I have negative 4 times 78125. I'm taking that big number, multiplying it by negative 4. A sub 8 is equal to negative 312,500. And that is the answer to number 4. All right, number 5, given the first term and the common difference of an arithmetic sequence, again, super important to know what we're working with, find the term named in the problem. Okay, so we're actually trying to find term number 28. That's what we're solving for. It is an arithmetic sequence, so we're using the arithmetic formula. A sub n is equal to a sub 1 plus n minus 1 times d. Okay. So then we're trying to find a sub 22. A sub 22 is equal to a sub 1 is 16 plus, we do know what n is. N is now 22. And we know what the common difference is because they give us that, times 9. So 16 plus 21 times 9. 21 times 9 is 189. And 189 plus 16 is 205. So a sub 22 is equal to 205. I'm going to see if there's a way that I can make this more visible for you. Oh, that made it worse, so let's not do that. There it is. Okay, so again, a sub 22, this value right here that I circled is your n. We plug it into the formula, 16 plus 22, we know this is n, minus 1 times d is given to us. All right, let's move on to number 6. Number 6 is asking us, given the first term and the common ratio of a geometric sequence, find the term named in the problem. Okay, so this is the same problem, but now we're dealing with a geometric sequence. So now we're dealing with a sub n is equal to a sub 1 times r to the n minus 1 power. A sub n we know is 10. So we're doing a sub 10 now instead, so that means n is 10. A sub 1 they give us is 4 times r they give us, which is 3. N again is 10. Now I have a sub 10 is equal to 4 times 3 to the 9th power. So 3 to the 9th power is 19,683. And 19,683 times 4 is equal to 78,732. Okay, let's move on to number 7. Evaluate each arithmetic series. Okay, again, super important to know which one we're dealing with. We're dealing with an arithmetic series. That means we have the sum of an arithmetic series. So I'm going to just write the formula here. S sub n is equal to n times a1 plus an. Now sometimes you'll see this formula written as n divided by 2 times this, or you can have all of this divided by 2. It's the same thing. Okay, so I'm going to write it both ways. Same thing. All right, so this is the summation. So this is sigma notation. Okay, so the sum from n equals to 1 to 40 of 10n minus 18. So this is your lower limit. This is your upper limit. This is your explicit formula. Okay, so just so you guys can remember, this n is just telling you that the variable you're using in your formula is n. It is not the quantity of terms. To find the quantity of terms, you take your upper limit minus your lower, then you add 1 to it, okay? So just remember that. That's how you find your n, or the quantity of terms, when you're doing the summation. All right, so let's do this. S sub n, so let's find n. N is 40 minus 1 plus 1, so it's still 40. And that's equal to, we know that n is 40 divided by 2 times a sub 1. So how do we find a sub 1? Well, you take this right here, plug it in. So 10 times 1 minus 18. And how do we find a sub n? We know what n is. N is 40. So we take 40 and plug it in and find our two values that we need. So 10 minus 18 is negative 8. And a sub 40, and that is 10 times 40 minus 18, is 382. So then back in our formula, a sub 1 is negative 8 plus a sub n, which in this case a sub 40 is 382. Gonna type that in. So negative 8 plus 382 times 40 divided by 2 is 20. So we have 7,480. Okay, let's move on. So this doesn't give us the sigma notation, but it's still the same thing. It's asking for the arithmetic series. That means we are finding the sum. So S sub n, we know what n is. They give us n, which is 5, is equal to n, which is 5, divided by 2 times a sub 1 is 22 plus, oh, but they don't give us the a sub n. So to find a sub n, in this case a sub 5, we have to go back to the explicit formula for the arithmetic sequence, which is a sub 1 plus n minus 1 times d. We know that n is 5, a sub 1 is 22, and common difference is 10. They give us that information. So 22 plus 6, oh, just kidding, this is 4, I can do math, times 10. So 22 plus 40, 4, 5, 62 is a sub 5, or a sub n here. So a sub n, sorry, my paper keeps moving around. A sub n, a sub 5 is 62. So then I'm going to use my trusty calculator. 22 plus 62 is 84. 84 divided by 2 is 42 times 5. S sub 5 is then equal to 210. Again, what I did is I added inside my parentheses. I then divided by 2, then multiplied by 5. So I technically was using this formula here, but it still should work. Don't evaluate this. Don't make this into a decimal. Don't do that. Okay, number 9. Okay, a sub 1. This was just it's a series, but it's just listing out the numbers, so we have to kind of figure stuff out. So a sub 1 is 22. We know n, they give us n is 9. So we know that it is an arithmetic series, so I can do find a common difference. So what's the pattern? I am adding, what am I adding? 29 minus 22 is 7. I am adding 7 each jump. It doesn't tell me what a sub 9 is, so again, I have to do what I did here to find a sub 9. So a sub 9 is equal to a sub 1, which is 22, plus n minus 1 times our common difference. And again, what formula am I using? I'm using this formula. Let me actually change that to n so we can have an actual generic formula. So this is the explicit rule for the arithmetic sequence, and that's the formula I'm using here as well to find what a sub 9 is. A sub 9 is equal to 22 plus 8 times 7. So 8 times 7 is 56 plus 22. A sub 9 is 78. I'm going to put a thinking bubble here to separate my work because I'm running out of space as usual. So then S sub 9 is equal to 9 divided by 2 times a sub 1 is 22 plus a sub 9 is 78. So 22 plus 78, that is 100. 100 divided by 2 is 50. 50 times 9. S sub 9 is then equal to 450. Okay, number 10. Number 10 is asking us to evaluate each geometric series. So again, different formulas. Now in this geometric series, we notice this is a finite geometric series. We know it's finite because it tells us what the end term is. So the finite geometric, the sum of a finite geometric series formula is S sub n is equal to a sub 1 times 1 minus r to the n power. And I'm going to put r in parentheses, all divided by 1 minus r. So again, how do we find our n? N is we take your upper minus your lower plus 1. And this is in case your lower limit is not 1. If your lower limit is 1, then your n value will be 9. But if your lower limit is not 1, then we have to figure it out. In this case, n is still 9. A sub 1, now it looks like they don't give you much information, but they actually give you all the information you need. If you look at your explicit formula here, this is a sub 1 times r to the n minus 1 power. Now instead of n, they're using m, and that's okay as long as these two match, it's fine. So then I know that a sub 1 is 4. I also know that my common ratio is negative 4. They give us a lot of information with this. So S sub n, what is n? N is 9, is equal to a sub 1 is 4 times 1 minus common ratio is negative 4. This is why I put r in the parentheses. To the 9th power, n is 9, all divided by 1 minus 9. So let's take a look what this is. Negative 4 to the 9th power is a big number. So what I'm going to do instead is I'm actually going to just type all of this in my numerator into my calculator just like it looks like. So I'm typing in 4 parenthesis 1 minus parenthesis negative 4 parenthesis to the 9th power parenthesis. Okay, and I'm going to write that down. So S sub 9 is equal to this big number. And that's all being divided by negative 8. Let me look here, 9. Ooh, give me 1 second. Let me redo that because it looks like I did something wrong. So let's double check that. Let's make sure that I know what I'm doing. So 1 minus negative 4 to the 9th power is 262,145. And that's being divided by negative 8 and multiplied here by 4. So 4 times 262,145. That's a big number divided by negative 8. And what's tripping me up, you guys, right now is my calculator is giving me a decimal. And I know for sure it's not a decimal because my common ratio is a whole number and my starting point is a whole number. So I'm thinking about kind of what's happening, and I don't think I should be having decimals. So let me do this for the third time, right? Third time's the charm. Let's see if I did anything wrong here. A sub 1 is 4. 1 minus negative 4 is r to the nth power, n is 9. And then 1 minus r. Oh, do you see what my mistake is? Did you catch my mistake? This should be an r value, and I put n here. So this is what's tripping me up. That should not be 9. That should be negative 4. And that's going to solve all of my problems. Oh, I'm so happy I found my mistake. I hope you caught that earlier than I did. I truly do. So that means my original number that I had was correct for my numerator, which was 262,145 times 4, all divided by, this time it's divided by 5. Okay, so let's make sure that that gives me what I need. And it does. I'm very happy, more happy than you can imagine. So this is 209,716. That makes me very happy. All right, let's do number 11. Number 11, again, they just list out the terms. They don't tell you what everything is. So I'm going to just draw a little separator here. So a sub 1 is negative 4. I know it's a geometric series because it tells me. So I know that I'm going to be multiplying. And it looks like I'm going negative, positive, negative, positive. So that means my common ratio will be negative. And how am I changing numerically? I'm changing 4 to 16, 16 to 24. So it looks like I'm multiplying by 4. I know my n value is 7. So I'm looking into my formula. S sub 7, I know what n is. N is 7 is equal to a sub 1 is negative 4 times 1 minus r is also negative 4 to the n power, n is 7, all divided by 1 minus 7. Oh, I did it again. I did it again. I don't know why I keep doing that. R is negative 4. I'm very happy I caught that earlier than last time. Okay, so let's type this into my calculator. So I'm doing negative, let me try doing this again, just typing in just the numerator. So negative 4 parenthesis 1 minus parenthesis negative 4 parenthesis to the 7th power parenthesis. And I get negative 65,000, took me a second to figure out how to say that, negative 65,540 divided by 5. And that gives me, for the sum of the 7 terms, negative 13,108. And that's a comma, not a decimal comma, right? Just 3 more here. Number 12, determine the number of terms n in each geometric series. So again, geometric series. And we are going to find what n is. So they tell us, first of all, do we know if it's finite or infinite? Since they want to know n, They want to know the quantity of terms. That means it can only be a finite geometric series. So we're still using the formula we used for numbers 10 and 11. So S sub n is equal to a sub 1 times 1 minus r to the n power, all divided by 1 minus r. Now, it's asking for us to solve n, so we don't know what n is, but we do know that a sub 1 is 2. 1 minus, we know that r is negative 3. We still don't know what n is. And 1 minus r is negative 3. And then it also tells us that we know what S sub n is. So S sub n is equal to 1094. So we're going to kind of solve things. I'm going to start writing up here because I have a little bit more room. So this right here, I know that this is 4. So I know that 2 divided by 4, this is 1, this is 2. So in my numerator, I have 1 minus negative 3 to the n power divided by 2. And that's equal to 1094. I'm going to multiply both sides by 2 to get rid of my denominator. So 1 minus negative 3 to the n power is equal to 2 times 1094. That gives me 2188. Adding 1 to both sides. So this one goes away. Oh, subtracting. Excuse me, I am subtracting. This one is positive, so I am subtracting 1. So I have negative 3 to the n is equal to 201.8887. I'm going to multiply. Do you see how there's a negative out in front? So I'm going to get rid of that negative by multiplying everything by negative 1. So what I have is negative 3 to the n is equal to negative 2187. Now, in order to find what these equal, we need to rewrite this right here in terms of negative 3 to some sort of power. When the bases are the same, then the exponents equal. So then we can say after this, n is equal to something. So I'm going to use my calculator. I'm going to say negative 3 to the, I don't know. I know that it's going to be an odd number for my exponent because this is an odd number here. So let's try, I don't know, 7. And I'm laughing because my first guess did end up getting being correct. So negative 3 to the 7th power, that means n is 7. N is 7 for number 12. Okay, number 13 and number 14 will require a little bit more space. Let's see if I can fit that in. I don't know if I will. Let's see. I'm trying to bring this into focus so you guys can see. So this is an infinite geometric series. Okay, so there is finite and there is infinite. So we must know the formula. Okay, so I'm actually cheating here just a little bit and I'm looking up the formula as we speak, just so that way I can provide a formula that is correct for you guys. There it is. Okay, so the formula for the infinite one, I'm going to write it here in a thinking bubble because we're going to use it for both. The formula is S sub n, or S sub infinity, is equal to a sub 1 divided by 1 minus r. Now this is the super duper important part. The common ratio must be less than 1. Okay? If the common ratio is greater than or equal to 1, it diverges, and that means no sum. Okay? So we must have it we must have it less than 1. The absolute value of our common ratio must be less than 1. So again, they don't give us much here, but they actually do. They give us everything we need. So we know that our lower term is 1. We know that our upper term is infinity. So there is no upper term, meaning it is an infinite series. Now, this is our explicit rule. So we have a sub 1 times r to the n minus 1, but instead of n, they're using I, which is fine. So that means a sub 1 is 4. R is equal to negative 1/2. Now in my head, what I'm doing, I'll write it down here. I'm trying to save room, but I will write it here. In my head, I'm doing the absolute value of 1/2 is 1/2, which is in fact smaller than 1. So yes, we can solve it. You must check your common ratio. So S sub infinity is equal to A sub 1, which is 4, 1 minus R, which is 1/2. So I have 4 divided by 1/2, and that should equal to 8. So as the geometric series approaches infinity, as n gets exponentially large, we get closer and closer to 8. Okay, let's try number 14. Number 14, again, whenever you're dealing with fractions, just find the pattern on the top, find the pattern on the bottom. So this pattern I'm seeing is times 3 divided by 3. So we're going smaller. So 9 to 3, so we are dividing by 3 or multiplying by 1/2 on the bottom. And then 1/3. And the top we're multiplying by 1 over, what are we doing? 2. Over 2. Another way you can do this is going backwards. So 6 to find R, that's what I'm doing. I should probably tell you what I'm doing. R is equal to the right divided by the left. So 6 divided by 4, and this is 3, and this is 2. Now notice that I have a 1/2 here and a 3 here, and both of them are being multiplied. And how do we deal with fraction over fraction? Is multiplied by their reciprocal. So that means this right here would in fact be 3/2. Now before I continue, I'm checking. The absolute value of 3/2 is 3/2, which is 1.5, which is greater than or equal to 1. So that means the series diverges, and therefore, this is 3 dots, is therefore no sum. So you actually don't have to do anything in number 14. So having it diverge saves you a lot of time and work. All right, that's it. This is the end of part 2. I hope you enjoyed it. I apologize for the hiccup somewhere that I made in here. I'm pretty sure there are plenty of mistakes. If you catch any mistakes, please let me know. Again, I am human. Just let me know where the mistakes are, and then I will fix them. Hopefully there are no more mistakes. But again, I am human, and mistakes can and will happen. Thank you so much for watching. Take care.